Hello, my name is Daksh, and I'll be explaining memory management. A bit of a context here before starting. When I started programming, I didn't know how programs run, what makes a program good, and why main security issues are generally related to memory. So, I'll be explaining memory management in Rust, Go, and C++, these three languages. So, the first question we can think of is what memory really is. So whatever device you can think of, mobile, laptop, vending machines, anything that is not analog might have a memory. And inside that memory, a program is executed. Your applications are run. Example, the Chrome, the VS Code, the screen which you are watching on, the YouTube. These are all loaded inside the memory. Also, the RAM is very costly, so it becomes really important. RAM is also memory, short-term memory. So it becomes very important to have less space complexity so you can run multiple programs at once. Now you know in DSA why space complexity is also required. All right. Now memory has two parts, but if we take the code also into account, then we can say it has generally four parts. I'll be explaining those four parts now. All right. Let us change this. So before explaining those, I'll be explaining the code flow in compilers and interpreters. Why is it necessary? Because as I told you, the code is also a part which is loaded onto the memory. So if you have studied, the code is tokenized and an abstract syntax tree is created for the code. So consider you have a code. The first thing which happens to the code is it is passed on to a lexer. What Lexer does is it creates tokens for that code, and then these tokens are passed onto a parser where an abstract syntax tree is created. If you don't know what these things are, it is not necessary. Just consider the last thing, that an AST is created. Now based on your language, this AST is then passed on to a compiler. Consider your language is C, C++ or Rust. Then in compiler, what happens is it creates the AST into bytecode. This bytecode can be run later uh, by double clicking the .exe file if on Windows, or you can run this bytecode directly on the terminal. This bytecode stores all the code which you wrote. So this is what compiler does. It creates the bytecode which can be used later. And consider if you have an interpreted language like Python or JS, then it is passed on to an interpreter. What interpreter really does is it creates and executes bytecode at runtime. So it doesn't at the end of passing doesn't create the bytecode which you can use later. It just creates it, runs the program, and at the end it deletes everything. So this is a difference between the compiler and the interpreter.